This question looks impossible. Like, how on earth we want to work out which of these is the longest until we spot a little trick. And that is to connect it up, to make it a bit more symmetrical. Okay, because now I've got this 4 here, which means this is also going to be 4 because we've got a line going from a corner up to here, same here, and they've got exactly the same base because it's a square. So if I just repeat this for the other ones, I'm basically creating lots of triangles that are exactly the same. Okay, that's like step one to realize. I mean, what else can you do, I suppose, but I don't think that's an obvious step. So because this is 2, then this one is also 2. And because this whole thing is 5, that means this is 3, which means that is also 3. Similarly over here, this must be 4, which means this is 5, because the whole thing is 9. So this is 5. All right, we've just got these missing triangles here, but we've not yet used the fact that the square has area 30. So if I do 2 plus 3 plus 5 plus 4, that is 14, double it to give 28. The extra area must be 30 minus 28, it must be 2. Because both of these are the same, they must have area of 1. Now you can maybe just take a guess at this point and say, hey, this one here is the biggest, so it must be D. Okay, and you would be correct, but let's just explain why. So each triangle has a base along the diagonal. Okay, remember, area of a triangle is a half base times height. So I want to look at the bases because then the area is going to be related to that. It's going to be strongly related because the area of a triangle is half the base times the perpendicular height. And all of these triangles will have exactly the same perpendicular height. As I move it along, it seems very strange finding the area of this triangle. This one down here by doing the base times the perpendicular height divided by 2. You'd probably think to times by, this one and this the height, but you can do it in different ways. That's the beauty of the area of a triangle. So same perpendicular heights as we move along. Okay, well, you have to trust me on that. I've made it actually a bit too big. Okay, that's a bit better. Yeah, they've all got the same perpendicular height. And so what I'm trying to say is that the area is simply going to be proportional to the base. Because they have the same perpendicular height, the only thing that is different is the base. And so because this one is the largest, it must be that D is the largest base, and hence which part of the diagonal is the longest, it's going to be D.